Hello, I'm Jagan from Grow with Data. Welcome to the Crack SQL Interview in 50 question series. In this video series, we'll practice 50 SQL questions across various topics. You can use the playlist Crack SQL Interview in 50 questions to follow the videos related to this series. If you go to the Grow with Data YouTube channel, you have all the videos, and if you go to the playlist, you have the Crack SQL Interview in 50 questions. If you click on that, you can see all the videos related to that. So you can play around with all the videos. If you want to get the code, you can go to the descriptive section and you have the code here. So when you click on the GitHub, you can see the create script and the SQL part of it. Okay, so today what we are going to do is we are going to work on a new question which find the average time for each machine takes to complete a process. So assume we have a factory production site that has several machines each running the same number of processes. We have to find a solution to find the average time each machine takes to complete a process. So when you say complete the process, that means we have a end timestamp and a start timestamp. Find the difference between that will give the time taken to complete a process, and then find the average of it at the machine ID level. The result should be at the machine ID and the average time, which is the processing time, and then you can round up the average time taken into 3 decimal places. It can be of any order, right? So first we get the table structure and the data. So we have the activity table which got the machine ID, the process ID, and then the activity, whether it's a start or end, and then the timestamp. If you see the machine 0, the process is also ID is 0, and it starts at 0.712 and ends at 1.52. So the time taken by machine 0 for process 0 is 1.52 minus 0.712. Same way for machine 0 for process 1, the start time is 3.14, the end time is 4.12. So the time taken is 4.12 minus 3.14. Same for machine 1 and for machine 2. So all the machines will have process 0 start and end, process 1 start and end. So they have two processes. We have to find the time taken by each machine based on the start and the end time. Okay, so let's create the table, and the expected output is going to be the machine ID followed by the average processing time, right? Okay, so the question looks simple, and if you have went through the previous videos, you might have came up with the solution how to do it. Even our previous videos, we talked about something called SelfJoint, where you connect the same table twice and then you refer the data set within the table, whether start, end, or when it begins, when it ends, and then if you want to compare between the first step and the second step, all that can be handled using a SelfJoint. So same thing, we are going to start with a SelfJoint for this question, because we are going to get the start and end date of the same data set. Okay, so okay, let's start with our select statement from activity. We just say it can be a start, inner join activity, this can be the end activity. On the connection part is the end dot machine ID equal to start dot machine ID, and it has to be two ways, right? So we have to find the machine and then the process. E dot process ID equal to start dot process ID, right? And then we have to define which one is going to be the start table, which one is going to refer the end process of the table. So we just say E dot activity type, so dot equal to end, and S dot activity type equal to start. So that is the reason I give the alias name as S and N to make sure we understand S stands for start, E stands for end. You can give any name, but try to give a meaningful name so that we can clearly define what is going to refer the start activity, what is going to refer the end activity. Okay. So here E points to end, S points to start. So what are the things we need? We need the machine ID, and then we have end time stamp from the end table minus S dot timestamp, right? So this will give the difference between the process, like start and the end, right? So here they say it's a timestamp, but still a float variable. If you see the data type, it's float. It's not a date or a timestamp part of it. So we can simply use the a minus b, right? It's just a float number. It's not a date part of it. So when you run this, you see it get all the machines like machine 0, machine 1, machine 2, and it find the process end minus process start. But we want to find the average part of it, right? So we just say average, and then when you do average is aggregate function, so we have to go for group by machine ID, which is column 1. So now if you see, we don't give the alias name, it's a processing time. Okay. So now you get the machine ID 012 and it's 9893994, but the question says we do the round to 3 decimal and there is no condition for the order by. So to do round the numbers, we just say round to 3 decimal place. So you got the answer. So we haven't done any order by. If you want, you can just go with the machine ID. Okay, it's already been ordered 012. So it's a simple self join where we take the activity table twice, and then the machine ID and the process ID are the connecting dots, right? So for this machine, this process, the one table refers to the end record, one table refers to the start record, right? So we have the activity type equal to end and start. So this record will be pointing by the S table, which alias name S. This will be pointed by the alias name E. So we just say E machine ID equal to S machine ID and then the process ID, and then we are saying E points to end, S points to start, and then we say E dot machine ID, right? We can even say S dot machine ID because it's the inner join, nothing is going to change. So if you run it, you get the same answer. When you do a left join, then you have to be sure that we have to use the right alias name or right table, which is primary or secondary, to get the valid result. Since we have inner join, there is no difference for referring to the E or S. And then we get the time difference between the end and the start, because end is greater than start, right? So it's end minus start, and then we take the average of it. We can say sum by count, that's a different formula, but we can simply use average. And then since they ask for 3 decimal places, we just round it, and since we use aggregation function, we just use group by, and we did the order by as a optional condition. So this is very straightforward and a self join concept which we referred in our previous video, in our 9th video, right? And we have few more examples. If you want to watch the previous videos, there is more detailed explanation of what is a self join. Fine. So for the next approach, we can try something called the Windows function, right? We just talked about a lot about Windows function. We have few examples on row number, dense rank, and last few videos we talked about the lead and lag function. So for this scenario, we can use both lead and lag. If you are using end as the reference table, we can use the lag function, so it goes backwards and find the start. If we use start as the reference function, we use lead to get the next function, the end function. Let's do the lag, because our previous video we tried the lag function, right? So let's say select from the activity table. So the Windows function, we have to we can refer only once. We don't have to bring the table more than once, right? That's a big advantage of it. And we can have all the columns also. Machine ID and then the process ID, and we have what is the timestamp or the activity type, and then the process time is the timestamp, right? So this is the normal columns we have, and then we are going to say the lag function. First try with the activity type. Okay, activity type, one is go one record behind over partition by, because we have to find for the same machine, for the same process ID, what is the start time, right? We don't have to look for the other process. So we partition by the machine ID and the process ID, and we say order by the machine. No need for machine ID and process ID, just for a standard I am just using it. And then the key part is the timestamp as start, you can say start activity type. So let's run this and see what happens. We need more space for this to see the record. Okay. Okay, so the alias name is start. Okay, now it looks better. So if you see the data, we have machine 0 and process ID 0. The end process have 1.52, right? So if you see this, end have 1.52, and the previous record goes to start, right? It just comes here. But when you have the start, if you look for the previous record for the machine ID and the process ID, there's no record, so it comes as null, right? So our lag function works, but instead of activity type, we can bring the timestamp, right? So we can just, oh sorry, not this guy. Oh, it's right. We can have the timestamp here as start timestamp. Okay. So when you run this, if you see the data for machine 0, for process ID 0, the end time is 1.52, which is here, and the start time is 0.712, which comes in the lag function, right? Same way for 4.12, machine ID 0, process ID 0, so process ID 1, 4.12 starts with 3.14. So 4.12 starts with 3.12, right? But the pain part is we have the start record, right? We have start record with the null value. We have to filter it out. So to filter it out, if you give the condition here, where we just say activity type equal to start. If you filter here, what happens is it will filter out all the end. Sorry, we would look for the end. So you'd look for only the end record, but the start record will be filtered out. So when you run the lag function, it will bring all 0 because all null, because for this end there is no other record starts with the same machine ID and process ID if you filter the start. So this record will be gone, right, if you get only the end record. So we can't do a filter at this level, If you do it at this level, it will completely filter out all the start record, so the lag function is not going to work. So what we can do is we can use a CTE function, raw data details as, right, we can have this, and then we just say select star from raw data details. Here we just say where the activity type equal to end. When you do that, now you get the record, the timestamp and the start timestamp, right? We can just say the end timestamp for make more sense. End timestamp, right? Oh, okay. So that is why we have to install our own software. If you have the browser part, that's the pain, right? Okay, so now you see for every end activity we have the end time and we have the start time, right? So using the lag function, we can bring the start and the end in the same record. If you want to see as a report, we can use this cross table to refer what is the start point, what is the end point, and if you have any other details, you can do that. That's the best part of the Windows function. But what we need is we need the machine ID and the average part of it, right? So we just say machine ID, and then we just say the average of end, what is the alias name, end TS minus start TS is the average, and then we have to round this to 3 decimal place, and the alias name we give is processing time, right? So when you run this, oh, group by, because it is average, right? So now if we see, we get the machine ID and then it calculates the average part of it, right? So both the steps are good, but for this scenario, the SelfJoint looks much simpler than the Windows function. But the best part of Windows function is we can see all the records in single row, the start and the end process. We can bring in all the records in the single row, and then we do it. Again, the last video I explained you, the Windows function are the database specific. So the SQL engine can perform faster than use the SelfJoint, where you use the same table twice. If there is like a millions of records, right? So millions into millions, right? So it's a bad join. So if you go with the Windows function, you call them only once, and the SQL engine can handle the Windows function much faster than the normal functions. So the performance will be much better. The main thing you have to look for is we have to get the lag function and then which column to bring in and partition part. If you don't bring in the partition, then the breakdown is going to be an issue. So we make sure we have a proper partition value, and then you order by the timestamp so that you know which one comes first, which one comes second. So the start time is always less than the end time. So you have to order by the timestamp so that you can get the previous record the right way. So based on your scenarios, you can use the SelfJoint or you can use the Windows function. Hope you like this video, and thanks for watching.